it's the current perspective in behaviorism or behavior analysis that says, yeah, you might have stuff going on up here. And I might could even tell you if I'm like sad or angry or happy, like I can tell you about a feeling, but we still can't study the feeling, but I could study what makes you say you have that feeling. Yeah, my name is Chris Farnan. I'm assistant professor of behavior analysis at UNT. I do research in animal behavior, so I'm interested in how animals learn, what they do, how that might be similar across some species, which includes humans, but I'm mostly interested in other animals, and also how they're different across species. So behavior analysis is really a part of psychology. Sometimes it doesn't get along with the philosophy of other types of psychology, but really it's a part of psychology. It's a part of other behavioral sciences, and it really wants to know, how does behavior work? I know that sounds basic, but that's really the core of it. How does behavior work? Why do people and animals do the things they do? But the philosophy is really what stuff in the environment causes us to respond in certain ways. Because as a behaviorist, I'm not saying stuff doesn't happen in the mind, but I'm just saying I can't observe it. I don't know what you're thinking. So the behavior analyst perspective is to only study what happens in the outside environment. So that means things you experience. If you're seeing something, I can see that you're seeing it. Things that you do, if you're doing something, I can see that you do it. Consequences that you experience. If you do something, what happens next, I can see that too. And so behavior analysis is really a sort of a philosophy in psychology, a discipline in psychology that really looks at what you do in response to what things happen around you. And from there we can look at all sorts of behavior learning, all sorts of problem solving stuff. There's a big movement in behavior analysis to try to create things that can help people, but I also like animals too, so I want to understand, well, how do animals work? And so when we say behavior analysis, usually we say like the behavior of organisms. So like anything that behaves, we can talk about. And that's really sort of the core focus of behavior analysis. And behavior analysis got a really big development when B.F. Skinner started inventing all sorts of things. B.F. Skinner is considered the founder of modern radical behaviorism. And so it's called radical behaviorism because he was like, no, we're radically different than the behaviors that came before us. And it's the current perspective in behaviorism or behavior analysis that says, yeah, you might have stuff going on up here. And I might could even tell you if I'm like sad or angry or happy, like I can tell you about a feeling, but we still can't study the feeling, but I could study what makes you say you have that feeling. And so it's a slightly different perspective on behaviorism that came before it that was a little more strict about those things. Skinner got behaviorism a lot more popular because of that perspective, but also because he was able to build everything and just do so much research and show things that nobody was doing before. And he was making, you might hear Skinner boxes for rats and pigeons, and these are like a little automated chamber. You can put a pigeon in or a rat in, and it can press buttons, it can get food, and you can automate it. And the automation is actually really important because you can, like, nobody wants to stare at a pigeon for 5 hours to do a study. You can get some really high resolution data. You can do different types of experiments that you couldn't do normally. And technology has been like a really big deal for that. It's this sort of automated operant chamber. Before Skinner, it might have been common to have like a rat maze, and a really simple maze is called a T-maze. Rat starts out in the center, and you go forward, and then you can go left or right. And so if you do that a bunch of times, and to say the food's always on the left, the rat's gonna learn, oh, I go to this side. But it's like a true-false question. And if you've ever taken a test, like true-false questions are like, that's what you want, right? That's easy. And so that sort of approach didn't provide as much stuff as Skinner's really advanced automated equipment could provide. So when Skinner was able to put some new frameworks out there about how behavior works, was able to create some new equipment, and even new equipment to create graphs that could show data in real time, that really gave behaviorism like another big movement. And so that's sort of where we are. We've built on that, and it's not as popular as it used to be, say back in like the 60s or 80s, but it's still a really healthy field, and it's really inspired by Skinner and then a lot of his predecessors. So Skinner did this, back in like the 30s and 50s, and it's been popular for a long time, but technology has been changing now. And one of the things that's been changing is it's gotten a lot more expensive because there's a lot of companies now that it's not always the scientist that's making their own equipment now. You have to go out and you have to buy stuff, and it gets so expensive. And the other issue is that the companies are making stuff just for like rats, pigeons, sometimes not even primates, maybe even to investigate learning in dogs. And I don't have it. This is not a primate lab. I don't have that stuff. I don't have rats here. I have insects. So I've worked with bees. I've worked with cockroaches. I've worked with rats and pigeons too, horses and other stuff, rattlesnakes. But I can't always go and buy the operant chamber for a rattlesnake. Look online, you'll not find it. If you find an operant chamber for rattlesnakes, let me know. So I have to go and build the stuff. And so for me, the technology end is really about like literal technology. It's like, how can I learn how to build all these things like Skinner did way back in the day? And so it's a lot of electrical engineering. It's a lot of working with microcontrollers. It's a lot of programming. And you have to also know how the animal works, right? To build something that's gonna work for the animal. So a lot of the work I do does involve different types of technology, and I'm always trying to, keep up with what sort of different things I can do. Computer vision, something I've been really interested in. Having a computer program that watches a video of an animal and tells you what it does. And you can buy some of that stuff for animals that people use a lot, but again, if I want to work with like cockroaches or something, I probably have to write that program myself. So one of the species I'm really interested in, I'm considering working with, is called the marbled crayfish. It's like a regular crayfish, but it is an all-female species that clones itself.